All right, so let's start with, this is week 5. Welcome, everybody. Of course, we talked about agent last week, and we're going to be building on agents. So hopefully everybody who did a presentation with their schematics, hopefully you still have them, but we do have them anyway. So what we want to do is at the end of the class, we want to talk to you about actually where you are with those, and we want to end up starting to build on those. Musa will take lead with that as far as what applications you use. We're all joining on that, but what I wanted to do this week was talk about critical thinking, because critical thinking is very, very important, and that's all AI guys talk about today. When you hear the AI guys talk and about AI, the future of it, what you need to do, one of the first things they always talk about is critical thinking. So today we're going to talk about critical thinking for tech creators, how 10 essential skills power the future of AI games and software. And also, I'm going to upload a link. That link is to an AI game. It's not a game, it's a critical thinking thing where you can pick, say for instance, you could just say, yo, give me the top 10 or give me let's learn, let's teach. So it's going to give you what we're talking about right here, the top 10 critical thinking we're talking about right here, that app is going to give you. So how 10 essential skills power the future of AI games and software. Think smarter, build better, and launch faster. What we'll explore: 10 critical thinking concepts that power successful technology development. Number 1, identifying assumptions. Question unstated beliefs. Number 2, evaluating evidence. Assess quality and relevance. Number 3, recognizing bias. Spot prejudices and judgment. 4, logical fallacies. Find reasoning errors. 5, causal reasoning, correlation versus causation. 6, perspective taking, consider different viewpoints. 7, asking clarifying questions. Seek understanding first. 8, fact versus opinion, separate objectives from subjective. 9 is analyzing arguments, break down and evaluate logic. 10 is metacognition, think about your thinking. Number 10 is one of the most important, because even if you question yourself, do you even think about things? Most of us really don't. We just, spit stuff out and just keep it going, and we don't even think about some of the things that we actually say. So, why critical thinking matters in tech? The foundation of innovation. Every app, game, and software platform you use was built by people applying critical thinking skills, from debugging code to designing AI agents. These skills are the invisible engine behind successful technology. Real-world application. Tech companies use these skills daily. Product managers evaluate evidence to decide features. Developers question assumptions to find bugs. And designers consider diverse perspectives to create inclusive experiences. Skills for life. Whether you're coding your first app, designing a game, or navigating information online, critical thinking helps you build better, decide smarter, and learn faster. These aren't just tech skills, they're real life skills. So for building AI agents, developers must identify assumptions about user intent, evaluate training data quality, and recognize biases in AI models. Game design. Designers use causal reasoning to understand player behavior, take perspective of different player types, and question what makes games fun. Because if we think about it, we just go off the floor of what we feel, and that's bias. SaaS platforms, what me and Musa was just talking about. Product teams analyze user feedback, distinguish facts from opinions, and reflect on what features truly solve user problems. This is really important, man, because the person who really critically thinks is going to be on the winning side. The person who don't critically think and take the time to critically think is going to be on the loser side. Because thinking, what I realize, it takes some work, and it does fire off your neural networks. The more you think, the more you're actually firing off your neural networks. Talking and things like that, yeah, you're firing off some neural networks, but when you put a strain on your brain is when you're really firing off those neural networks. When you make that brain go into thinking mode is when you're firing off your neural networks. And that's what you want to do when you're using AI. That's what you want to do when you're building a game. You want to make sure your brain is functioning instead of not functioning, and you're letting the AI do all the thinking for you. So reality check. Play testing reveals 60% of players skip tutorials. Solution. Integrate learning into gameplay instead. Tutorials are very, very important. And I myself be skipping tutorials. And tutorials are important, and we're going to show you why. Key insight: the most expensive mistakes in tech come from assumptions that go unchallenged. Always ask, what am I taking for granted? Practice. So this is what I want y'all to do. I need you to write down the students and the TAs. I need them at the end. I want to ask them this. I need you to list 3 assumptions you're making about your next project. You know what I'm saying? Just even if you could do 1 or 2. If you could do 3, do 3. Nate, Felix, whoever's on, give me 3 assumptions. Just what 3 things that you think about your app. And that's it. It doesn't have to be bad. It doesn't have to be good. And let's just see what it is. Evaluating evidence. What does it mean? Evaluating evidence means assessing the quality and relevance of information that supports arguments and decisions. Not all data is created equal. SaaS product example. User requests. 500 plus users request dark mode via support tickets with specific use cases. That's actually strong evidence. One user's tweet, single complaint about interface color, may not represent broader needs. That's weak evidence. So even if you get 1, 2, 3 people saying, yo, we want to change it to dark, but then you got 400 and something people not complaining, you're not going to really pay attention to that, because that's just a few people complaining. You can't go off that. But then when you have 500 plus users, you have to look at that and be like, you know what? We might have to change our dark mode, light mode to dark mode. Analytics data. Users spend 30% less time on the page. Is this bad engagement or efficient task completion? It needs context. You need to work on that. So we got evidence quality check. And this is all I'm telling you. When you're building an app, all of this goes into it. You have to, because there's going to be a better app, or else it's going to be an app just like everybody else's app if you don't use your critical thinking. So let's talk about evidence quality checklist. Source reliability. Is the source credible or trustworthy? Sample size. Is there enough data to draw conclusions? Relevant. Does this evidence actually address the question? Recency. Is the data current or outdated? Game analytics example. A game shows players quit at level 5 before redesigning. Is it too? Because you have to ask yourself, if you got 10 levels or 20 levels and everybody's quitting at level 5, you have to ask yourself, should we be redesigning? So what you want to do is you want to ask some questions first. Is it too hard? Are the players distracted? What do player testers actually say? Are they returning later or quitting forever? These are the things that are very important, because everything is data. Every question you ask, every answer you get is data. And this is the most important thing when it comes to artificial intelligence, is data. Because when you answer these questions, you're going to get the answers you need. And once you put them into the AI and formulate a prompt and say, yo, make this better, whatever it needs to do, you can do by getting the answers, getting the data. Because that's what companies do. They take that data. If a company goes into a school and actually implementing their AI into that school, the most important thing for that company is not the money they're getting from that school. It's the data that they're getting from that school. So move on. Evaluating. Recognizing bias. Understanding bias. Bias refers to personal or cultural prejudices that affect our judgment. Everyone has biases. They're unconscious shortcuts our brain takes. The key is recognizing them. AI bias, a real world problem. Facial recognition failures. I spoke about that before when we talked about CV, and that's why I always say those flashcards I gave you is very important, because everything we go over, one of those abbreviations apply to everything we do. Facial recognition, if you look at those flashcards, is CV, computer vision. So AI systems trained primarily on light-skinned faces showed significantly higher error rates for darker-skinned individuals. The bias came from unrepresented training data. Before I continue on, Felix, Nate, can one of y'all tell me why this happens? Okay, facial recognition failures. Facial recognition failures. AI systems trained primarily on light-skinned faces showed significantly higher error rates for darker-skinned individuals. The bias, I ain't gonna read the rest. Why do you think that's in the picture? Like, why is facial recognition biased to darker-skinned women?
Because they were mainly trained with lighter skin tones. They weren't trained with darker, or for example, let's say a white guy trained it and it recognizes primarily like white guys, Latinos, or light-skinned Latinos.
Right.
And then let's say a dark-skinned Latino tries it and it doesn't work.
100%.
properly trained.
Yes, 100%. And there's a woman, I can't pronounce her name. She's African. She's actually in my book. She's one of the ones that actually is the champions of making sure that this got better, because it got better, but it's still not 100%. And the problem is, just to show you how we deal in America, once they found out that these systems was discriminatory, some police states, some states decided to not use them. But then you have some police organizations in some states that said, nah, we're going to keep using them. And I mean, that's crazy if you really think about it, but that's what it is. So the critical thinking solutions, the developers now ask, who is represented in our training data? Exactly what Felix just said. Who might be excluded? What could go wrong for different user groups? Product launch retrospective. Questions the teams ask. What assumptions were wrong? What would we do differently? How can we validate ideas faster? The outcome. Teams that reflect systematically improve 2 times faster than those that don't. Metacognition in action. AI engineers reflect on why models make certain predictions. Game designers analyze why certain mechanics work or fail. Product managers question their own decision-making patterns. I mean, I don't know how to emphasize more importantly as far as metacognition. I think that is one of the most important parts of this critical thinking thing, because it's telling you to think about your thinking. And that's deep, man. And I'm telling you, this is a world that we're moving into now. This is not a world I grew up in where we had to think like this. And I think that's why we messed up now, to be honest with you. I think we should have been learning critical thinking, financial literacy, and all of this stuff. But now you have an opportunity. So I think metacognition is one of the most powerful parts of these 10 steps as far as critical thinking. The power of reflection. The people who regularly practice metacognition learn 10 times faster. Every mistake becomes a stepping stone when you reflect on it. So, let's analyze the games. Let's analyze what we're doing. Let's think about it 10 times, like not 10 times over, but think about it to make sure you learn 10 times faster.
So Eric, why is metacognition so important now?
Because do you think your thinking is always correct? Or do you assume that it's always correct? Yes, right? We always think our thinking is correct. We always think we're right. Am I correct? Am I right? So when we build something, we're basing it off our beliefs, our thinking. We're not thinking about someone who doesn't think like you. And that's what you need to do, because if you're building the game, you ain't building it for yourself. You're building it for the public. And everybody doesn't think like you. You know what I'm saying? So thinking about what you're thinking is very crucial in life, period, because that's what's going to happen. The person who thinks before they start building is the one that's going to win, because they thought about it. The person that just builds is just going to build off something that's giving them blocks to build off of. And they're not even going to really be thinking, So metacognition is very important. So.
Oh, and I was just thinking that when you were talking about the the topic that you were just talking about, right? I was thinking about, what about the biases? Like, it's going to be...
Right. You know what? I think I jumped to that when I should have, because did we do recognizing biases? No, right?
I was thinking it.
All right, so here, I'm gonna have to go back because I think I skipped. So recognizing bias, understanding bias. Bias refers to personal or cultural prejudices that affect our judgment. Everyone has a bias. And that's why in China, as far as podcasters, you have to be licensed now. You have to be certified in China. So even when it comes to recognizing bias, we all have biases, and that's why let's get back to AI systems trained primarily on light skin, significantly higher error rates. That's a bias. The critical thinking solution, who represented the training data, Let's go to game design bias, unconscious bias. Designers create characters that look like themselves and their friends, right? That's a bias, actually. Impact. Players from underrepresented groups don't see themselves in games. Better approach. Intentionally design diverse characters. Test with diverse players. And Marvin, that's why it's important to think about what you're thinking about, because you might be thinking wrong. And, it's a time thing. Some people don't want to take the time to do this. This is actually, it takes time. And that's the thing with AI. AI is rushing us through everything to where it don't want you to be critically thinking. And that's what people are doing. They're not. And they're the ones, to me, I believe that's not going to make it far. SaaS product bias, confirmation bias. Teams prioritize features that personally want, ignoring user data. Solution, actively seek disconfirming evidence. Use research with diverse groups. Logical fallacies. What are logical fallacies? Logical fallacies are common errors in reasoning that undermine the logic of an argument. Spotting them helps teams make better technical decisions. Common fallacies in tech decisions. Appeal to popularity. Everyone's using React. fact, so it must be the best choice for our project. Reality, popular doesn't mean right for your specific need. So don't just go with the flow. False cause. We added this feature and sales went up. So the feature caused the increase. Reality, correlation versus correlation is not equal to causation. Was it the feature, seasonality, or marketing? You have to figure that out. More tech fallacies. Slippery slope. If we fix this bug, will we have to rewrite everything? Appeal to authority. Google uses this architecture, so should we. Either or fallacy. We can either ship fast or ship quality. Pick one. So this is how you protect yourself from that, because these are all tech fallacies. These are things that, you don't have to do these things. So what you want to do is you want to ask, what evidence supports this claim? Consider, what would prove this wrong? Challenge, is this the only explanation? So practice. Next time someone makes a technical argument, identify if they're using all these fallacies. And like I said, I'm going to give you all a summary, so you're going to have all 10 of these, and then I'm going to give you the link so you can actually practice. Casual reasoning, correlation versus causation. Casual reasoning is about distinguishing between correlation and cause and effect. Just because two things happen together doesn't mean one causes the other. Game analytics example, the observation. After a game update, average play time increased by 40%. So the first thing you're going to think is, okay, it was because of the update, but that might not be the reason. The critical question, did the update cause the increase, or was it school vacation started? A popular streamer featured the game. Seasonal weather keeping players indoors. So automatically, because you do an update and you start getting traffic, you can be, oh man, we got the update. Yo, the update did it. But you're not really doing your homework. You're not really critically thinking that it could be other things. SaaS example, onboarding, the correlation. Users who complete onboarding have 3 times higher retention. So that alone tells you, most people are not reading the onboarding process, the tutorials. But the ones that do, if they have 3 times higher retention, means that they're 3 times smarter than you on that application. And that means you should be reading the onboarding process too, reading the tutorials too. The casual question, does onboarding cause retention, or are engaged users more likely to complete onboarding? Test, randomly assign users to different onboarding experiences to isolate the effect. The golden question, always ask, what else could explain this? This simple question protects you from making costly decisions based on false causation. Remember, ice cream sales correlate with drowning incident. Does ice cream sales cause drowning? No. Both increase in the summer. But let me tell you something. You know how easy it is for me to make you think in a conversation when you're not thinking? Yo, man, ice cream at Orchard Beach, every time they sell ice cream, you got mad drownings, but when they don't sell ice cream, there's no drownings. But is that really correlated? Is that really the case? No, but if I dig deep enough, I'm gonna have you believe that. Because that's how AI is. If I really deep and go hard with, nah, you crazy, look at the statistics. When the ice cream shop is closed, mad people be drowning. Not realizing, man, it's just the summertime. People are drowning because it's the summertime and they sell ice cream in the summertime. It has no correlation, but I can convince you. And that's how life is, and most people are going through life being convinced about stuff that ain't even the truth. Perspective taking. What is perspective taking? Perspective taking means considering different viewpoints and contexts. Great technology is built by understanding diverse users, not just designing for people like yourself. AI agent example. User A, tech professional. I want the AI to give me detailed technical explanations with code examples. User B, casual user. I want a simple, jargon-free answer that gets straight to the point. Solution, design the AI to adapt its response style based on user expertise level. So everybody's not gonna always try to ask for the same thing to get the same results. Game design perspectives, hardcore players. Hardcore players want challenging mechanics, deep systems, competitive features. So when you build your game, are you going to think about them? Are you going to think about casual players who want quick sessions, simple controls, relaxing experiences? Accessibility needs. Are you going to actually put it in for people who you think might have a handicap? Are you going to put something there for them? Voice, color codes or something, colorblind modes, screen reader support, adjustable difficulty, And me just thinking about that, to me, that should give you an idea. Wow, I wonder how many apps are out there for people who have disabilities. I don't think there's a lot. I believe that could be a moneymaker, you know? So global considerations, different languages and cultural context, varying internet speeds and device capabilities, different privacy expectations and regulations. Key insights, the best products aren't built for average users. They're built by understanding the full spectrum of user needs. So I think I think when you decide you want to build something, and I like what we did last week where Musa, we talked about building something for your community. So when it comes to they're built by understanding the full spectrum of the user needs, whatever you feel your community needs is the user needs. And that's why I'm glad we did build on doing something for the community. So also critical thinking concepts, of course, is about asking clarifying questions. Why clarifying questions matter? Asking clarifying questions means seeking extra information before judging or acting. Good questions prevent misunderstandings that cost time and money. SaaS example, the real-time request. Client says, we need real-time data updates. Critical thinker asks, what does real-time mean to you? Milliseconds, seconds, or minutes? How often does the data actually change? What happens if updates are delayed by 30 seconds? So if you're going to deal with this, you really have to figure it out. Like, what's real time? Is real time real time? Is it milliseconds? Is it seconds or minutes? A lot of people say real time and it's not real time. It's actually a pause. So if there's a curse, they can actually bleep it. That's not actually 100% real time. Result, turns out real time meant updates every 5 minutes, not milliseconds, saving weeks of unnecessary engineering work. Bug report example, vague reports. The app crashes sometimes, clarifying questions. What were you doing when it crashed? What device? Can you reproduce it? You need to know all of these things because these things might happen. Somebody might say, listen, man, the app crashed. You need to find out why, where, when, and how it can never happen again. Outcomes, specific information leads to faster, more accurate fixes. Powerful question type. What do you mean by? Defines ambiguous terms. Can you give an example? Makes abstract concrete. What would success look like? Clarifies goals. Why is this important? Reveals priorities. Remember, there's no such thing as a stupid question, only expensive assumptions. Fact versus opinion. What's the difference? Distinguishing facts from opinion means separating objective facts from subjective views. Both matter in tech, but knowing which is which helps you make better decisions. Game development examples. Fact, our game has 1 million downloads and an average rating of 4.2 stars. That is a fact. That's verifiable with data. Opinion, our game is the best in the genre and players love the art style. That's actually an opinion, subjective judgment. Which your opinions matter, but you can't look at your opinions as being fact. And that's one of the problems we have. We think our opinions are fact. Tech decision making. Fact, the algorithm has 95% accuracy on our test data. Opinion, this is the best approach for our use case. Why both matter, and that's why I said opinions do matter. Facts inform decisions. Opinions about user experience guide design. How to tell them apart. Facts can be verified. Can you measure, count, or prove it? Facts don't change, though our understanding of them might. Opinions vary by person. Different people can have different valid opinions. Opinions include judgments. Words like best, worse, beautiful, signal opinions. Key insights. Great product teams use facts to make decisions while respecting that user opinion about experience matter enormously. So opinions do matter, of course, but don't get it mixed up with facts. Analyzing argument. What is argument analysis? Analyzing arguments mean breaking down and evaluating the logic of claims and reasoning. Tech terms constantly debate approaches. Strong analysis leads to better decisions. Architect debate example. Argument A, microservices. The claim, better scalability and team autonomy. Evidence, can scale services independently. Counter, adds complexity, harder to debug. Argument B, monolith claims Claim, simpler to develop and deploy. Evidence, single code base, easier testing. Counter, harder to scale, individual components. So you're the architect of your design, so you have to figure it out. Like, I'm telling you, all this is important before you actually start the process, so you can actually know what prompt. Like, once you figure all of this out, you can make one prompt, throw it in, and create the game and have everything the way you want it to be. You might want to have a better scalability. You might want to have a simpler app to develop, you know? So the argument analysis framework. Number 1, identify the claim. What is being argued? Number 2, find the evidence. What supports this claim? Check the logic. It's number 3. Does evidence support the claim? 4, consider counter arguments. What would prove this wrong? SAS, feature prioritization. Evaluate which arguments have strongest evidence. Consider impact versus effort for each option. Test assumptions with prototypes. Remember, the goal isn't to win the argument, it's to find the best solution through rigorous analysis. So we're gonna go back to metacognition since we're here, because I'm sorry I did skip. I don't know how I got there from where we was. Once again, what is metacognition? Because this is the most important. This makes you 10 times more efficient than the one that's not thinking about their thinking. And I think that's important. 10 times more? Come on, that's crazy. Metacognition means reflecting on your own reasoning to improve it. So say for instance, you're thinking about something, you can actually put it in AI and say, listen, I need you to help me build on my thinking skills, you know? It's the skill of stepping back and examining how you think, your blind spots, assumptions, and patterns. Debugging example. After finding a bug, a developer doesn't just fix the bug, they ask, what assumption led me to this? How can I catch similar issues earlier? What process change would prevent this? What process change would prevent this? Result, each bug becomes a learning opportunity, making the developer more efficient over time. Product launch retrospective. Questions the team asks, what assumptions was wrong? What would we do differently? How can we validate these ideas faster? The outcomes, teams that reflect systematically improve 2 times faster than those that don't. Metacognition in action. And what I like about this one, it says teams that reflect systematically improve 2 times faster than those that don't. So, you know, that right there makes me feel like one day when we do have an in class, I think we should give you guys 30 minutes to all sit amongst yourselves and talk about your products, your apps, your agents. And I think that'd be a good idea for 30 minutes for us to leave y'all amongst yourselves, and then y'all sit back and tell us what y'all came up with as far as not working together on the project, but just working together, talking about your products. Tell us how that helped. You know what I'm saying? How will that make your next project, like, you know, as you're building on it, how will that make it better? You know what I'm saying? Getting ideas from each other. I think that'd be a good idea. Metacognition. All right, that's really it. Your critical thinking journey starts now. So these 10 skills aren't just for tech professionals. They're tools that you can use today. I know a lot of you probably are lost in a lot of the stuff we was talking about. That's why I'm gonna upload that summary, and I'm gonna actually give you that critical thinking link, so you can start practicing with critical thinking along with building your app. So whether you're coding your first app, designing a game, or just navigating information online, critical thinking helps you build better, decide smarter, and learn faster. The future of technology will be shaped by people who can think clearly, question assumptions, and learn from their mistakes. This person can be you. Think critically, build boldly, and learn forever. So basically that's the end of that presentation. And I'm telling you now, pay attention to what I'm gonna send you, because this applies to life. This don't apply to just no game. Because when you actually decide to use a GPT for a particular project, you might want to do some homework on that GPT. You know what I'm saying? Claude might be better. Claude Code might be better. Copilot might be better. It's different things that might be better for you. So sometimes it's better just to do your homework before you actually start the project, because it'll just make you think. It'll make your brain more healthier, and it'll get you further in the future. So